Hello viewers, this is Manas welcoming you to the series You the Oracle Expert, your one-stop shop to learn and practice Oracle database administration and Unix with hands-on experiments using Oracle VirtualBox virtual machines. Build your knowledge base, confidence, and make your way to be an expert Oracle DBA. So viewers, this is the second and final part of the topic on understanding and handling the most common Oracle locks in a simplified way. In the first part of this topic, we learned about Oracle locks, deadlocks, and blocking locks using a few test cases and some real-life examples. If you have not watched the first part, I suggest you watch that first to get a better understanding of the topic on today's video. In this tutorial, that is the second part, we are going to a little deeper on how to handle the blocking lock issues using traditional and Oracle Enterprise Manager. In day-to-day activities of a DBA, blocking lock is the most common type of performance issues that is encountered. So today, we are going to learn how to detect a blocking lock using SQL Plus, how to monitor blocking locks using OEM, and how to alert on blocking locks using OEM Metric Extensions. I'm using 3 SQL Plus sessions with system user to create the blocking lock situation and 1 session using Toad with sys user to capture the blocking lock related statistics. All the SQL statements that I am using in this sys session can be found in a text file in my Google Drive, and I have shared the link to that file in the description of this video below. And I have already created one test table in the system user schema. The name of the table is test log with 2 columns. The first column named N that stores the numerical values, and the second column called S that stores character values. And I have already inserted 3 records to that table, and these are the 3 rows: 1A, 2B, and 3C. And this second SQL statement we are using to get the information about all these 3 sessions established using system user, and the first session with the SID 76, the second one with 90, and the third one with 288. Now let's execute a simple DML or update statement in the first SQL session, then second and third, and we'll create a situation where the second and the third session will be waiting for the first session to release the lock on the test log table. And this update statement will be update test log set n equals to 4 where n equals to 3, and we'll execute a similar statement in the second session, but to set the value of the n to a different value. Say it's 5, but this session is also targeting the same row, so it goes to a hung state because the first session has not yet released the lock on the same row. Now we'll execute a similar statement but setting a value of n to say 6, and this session is eventually going to a hung state or a waiting state because in the queue of sessions requesting the lock, the first session already got the lock and it has not completed the transaction, so it's still holding the lock. The second session is waiting for the first session to release the lock and it is in a waiting state, and the third session is waiting for the second session to complete its transaction, and in the queue of waiters it is in the second position. Now if we try to extract the session information of all these 3 sessions using the same SQL statement, in the wait event or the event column, we will be able to see that the second and the third session is assigned with NQTX row lock contention. And we can see that these 2 sessions are having this wait event. Now this is a blocking lock situation. Until and unless the first session completes the transaction by either rolling back or committing the transaction, these 2 sessions will continue to wait, and this is a situation we often encounter in our database systems that creates severe performance issues with blocking lock contention. Now I'll go ahead and extract the blocking lock related statistics using this sys session from the database. Firstly, to detect blocking lock issues or blocking sessions using SQL Plus, we have a few different views in Oracle to get different piece of information about locks, which are $lock, $locked object, $session, DBA blockers, DBA waiters, etc. And I am using these views in my SQL statements. So the first one, it is using the $lock, this particular view, and also in a subquery, the same view is being used. And this is the most simplest of all SQL statements to extract the blocking lock situation, where it will give us which session is holding the lock and what is the lock ID, lock mode, and what type of lock it is, and which sessions are waiting. For example, in our case, the first session is the holder or the blocking session, and the next two sessions are waiters with SID 288 and 90, and the first one has a SID 76. Now the second SQL statement to extract the blocking lock related statistics is a little complicated, and it is joining multiple views from the views that I just mentioned, like DBA blockers, DBA waiters, $locked object, DBA objects, etc. And this will give us a lot of information about the holding session and the waiting sessions, like the holding session SID serial number, the user holding the lock, what is the lock type, what is the mode, which machine the sessions are established, and using what module, and also the waiting sessions SID and serial number, and what is the username used by those sessions, and what is the object ID of the table getting locked here, and the name of the object. So this is our test table with a name test lock. And now the third SQL statement that I am using here is useful in single instance as well as RAG databases, and it gives us all the information about what instance ID, SID, and serial number of the blocking and waiting sessions, because in a RAG database the blocking session come from one instance and the waiting sessions can come from different instances. So it is important to identify which instance the sessions coming from. And if you see, the first column is giving us the instance ID, SID, and serial number separated by some columns here, what session it is blocking, and for how many minutes. For example, we can see that the session with SID 76 here is blocking the other two sessions with SID 288 and 90, and their serial numbers are also there. And this session with SID 76 is blocking the other two sessions for 9 minutes. So this is a very useful information, because this will help us decide whether we should kill this session that is blocking the other sessions, or we should leave it to run for another couple of minutes. In a RAG environment, it is important to know about the instance ID from which the blocking sessions or the waiting sessions are coming. However, if you want, you can also modify the first two SQL statements to work in a RAG environment. Now this is how we can use SQL statements to detect the blocking lock situation in a database. Secondly, to detect the blocking session in OEM, we can simply go to the database homepage, and once we are in the homepage, we can go to the performance menu, then go to blocking sessions. And this gives us quite a few information, including the blocking tree, which is very useful to detect the root session that started this all. You can also kill the blocking session from this page to resolve the locking contention. For example, in our test case, the root session that is with the SID 76 is starting to lock a table, and it continues to hold the lock because it has not completed its transaction, and it is causing the other two sessions to wait. And this OEM page is giving us all the information about the SID, serial number, and what SQL statement those two waiting sessions are executing, and their wait event, etc., etc., and how many seconds they have been waiting. And if we want, we can kill the top session, that is the session holding the lock, from this page itself by simply selecting and clicking on this Kill Session button to resolve the locking contention. But these first two approaches, where we are using SQL statements to identify whether there is a blocking lock contention, or this OEM page where we are getting all the information about the blocking session, you already have to know the database where the locking contention is taking place. Well, you can set up some cron jobs or Windows batch job and put the SQL statement that I have demonstrated before to extract the locking contention information and send an alert by running those jobs periodically and check if there is any blocking contention happening. But the most effective and easiest way to achieve this, to identify a blocking lock situation, we actually need a mechanism which will alert us if there is a blocking lock contention happening in any of our databases and has crossed certain time limits such as 5 minutes or 10 minutes, and we can then take action before the situation becomes worse. So in the third approach, to detect and alert on blocking sessions or blocking lock contention, is to use a metric extension in OEM. If you are not using OEM, you can still use the SQL statements that I use to extract the blocking session statistic in a cron job or Windows batch job and periodically run that against the databases to see if there is any blocking lock situation happening. But doing this through OEM is really efficient. Now, to create the metric extension, we have to first create the SQL statement that is going to be used by the metric extension to extract the blocking lock related data. To create the SQL statement, we are going to take a copy of the existing SQL statement that we used for the rack instances, and we will remove all the columns except the column that is giving us for how many minutes the blocking lock situation has been there. So this last column that is aliased as for minutes is giving us for how many minutes the blocking lock situation is going on. So you can see that the for minutes column is 24 now. So there's a blocking lock situation going for the last 24 minutes. And this information we will use to create an alert. We'll make a small enhancement here because we don't need multiple rows. Instead, we'll need the maximum number of minutes that is the blocking session is taking. So we'll put a max function there. And this gives us one single value which is telling us what is the maximum number of minutes that blocking session has been there. Now we'll copy this SQL statement and we'll go to OEM, then go to monitoring, metric extensions. Here we are going to create a new metric extension by clicking on this create button, metric extension, and the target type for this metric extension will be database instance. So select database instance there, put a name like detect blocking session, and the display name will be the same, and the adapter will be SQL. The description will be ME to detect blocking locks. Data collection will be enabled, data upload will be yes, use of metric data will be for alerting and historical trending, upload interval 1, frequency by minutes, it will be run say every 10 minutes, then click on next button, and in the basic properties window, we'll put the SQL statement that we copied from our Toad window that gives us the maximum number of minutes that the blocking lock has been there. Click on the next button. Now we need to create a new column in this page. A column is nothing but a field which is going to accept the value returned by the SQL statement, and that value will be used to compare with the thresholds that we set to determine whether that alert is going to be a warning or critical alert. So we'll create a column first. Click on this add button, new metric column. Name will be same. You can put any name there, but we are keeping it as the same as the name of the field returned by the SQL statement. So for minute, display name will be the same, and it is a data column. Value type will be number, no unit, category will be, say, response, and the comparison operator will be used as greater than, and for warning we will put 1, and for critical we'll put 10. So ideally there should not be any blocking lock situation in a database. So that's the reason if anything blocking other sessions for more than a minute, then we'll consider it as a warning, and if it crosses 10 minutes then obviously it will be a critical situation and we need to take action on that. The manually clearable alert will be false, number of occurrences before the alert will be 1, and we'll customize this message and we'll make it more meaningful to us. Say blocking lock detected, and within bracket we'll put 4 minutes is the value. We'll copy the same message and it will be blocking lock cleared, within bracket the field name, that is the 4 minutes, is whatever minutes it is, and obviously for the clear message it will be 0. Click on the OK button, then click on next, and in this page we'll use the default monitoring credentials. Click next again. In this page we need to test our metric extension before we publish it against one of the target databases. Say we'll use this CatDB as the candidate database to test this metric extension against. Click on select, select this row again, run test. Because our blocking lock situation has not been resolved yet, so it is going to give us a big number here. So you can see that the 4 minutes column is returning a value 35, which is obviously more than 10 minutes, which is our thresholds for sending a critical alert. So our test has been completed. Click next, and everything looks okay. So we will click on the finish button. Now the metric extension has been successfully created. Now before we actually implement this metric extension or deploy it on our database targets, we need to save it as a deployable draft. To save it as a deployable draft, we'll select the metric extension, go to Actions menu, and there we'll click on the Save as Deployable Draft. And once it is saved as deployable draft, we'll select it again and click on the Publish Metric Extension. Once we publish it, it can be used by other administrators of this OEM system. So our blocking lock detection mechanism is in place and it has been successfully published. Now we'll deploy this metric extension on our database targets. For our example purpose, we'll deploy it only on one target database. To deploy it, select the metric extension, click on the Deploy to Targets, and then in this screen, we'll click on the Add button, select our candidate database. From this list, you can select as many number as you want for the target databases, but for our purpose, we'll select only one here. Click the Select button, and then we'll press the Submit button. So a job to deploy the metric extension to the target has been submitted, and we just need to refresh this page to see if the job has been completed. And yes, the entry has been gone, means it has been successfully deployed on our one target. Now our metric extension is designed to run every 10 minutes, and if you want, you can reduce to less than 10 minutes so that you don't have to wait 10 minutes for it to run and send you an alert. Usually, when you deploy the metric extension, it immediately runs for the first time, and ideally, in this case, we should also get an alert. You can always go to the target database. In our case, the target database is CatDB. Right click on the target, click on the Oracle database in the menu, then go to Monitoring and Metric and Collection Settings. And in this Metric and Collection Settings page, you will be able to see the metric extension that we just deployed. And in our case, this is the one that we just deployed with the name Detect Blocking Sessions, where we set it to run for every 10 minutes. And if you want, you can click on that and reduce the frequency to something like 2 minutes or even lesser. And then continue button. It will complain about the repeat interval being very low, but you can ignore it for our test purpose. And all you need to do is to press the OK button for the changes to take effect. But in this case, we'll cancel it. We'll go to the target database's incident page by clicking on the Oracle database menu, monitoring, incident manager for our target database. Now we see that at the top we have a critical alert. Blocking log detected for minutes is 45. So our blocking log has been there for the last 45 minutes. Let's select the incident to get the detail page, and once it displays the detailed page, go to the Events tab and click on the message again, and it will give us more details about what actions it has taken as per the incident rule set that we designed. And we can see that in the comment section, it has sent an email to my Gmail ID. Now in my inbox, I can see at the top there is one email that is coming from OEM system, and this is giving me all the information I need about the blocking log situation, from which database, for how many minutes, etc, etc. Now to resolve this situation, we'll go to OEM and kill this session. Go to the target database's home page, then go to the performance menu, click on the blocking sessions, select the session that has been blocking the other two sessions for the last over 45 minutes, and then click on the kill sessions button. It will ask for a confirmation. Click yes, and there is a confirmation that the session has been killed, and we'll be able to see that in the blocking tree, now the second session is blocking the third session. Because if you remember, we created a blocking tree by creating 3 sessions which were executing the update statement on the same row from the test log table, one after another. And if the second session is also continue to hold the log and don't do a commit or rollback of his transaction, then we have the option to kill the same session from here. Then again we'll kill it and click on the yes button to confirm the killing of the session, and now there is no blocking session in the database. If you want, you can also perform this kill session command from the SQL prompt, because we are already able to identify the blocking session, its SID and serial number. So using an alter system kill session with the SID and serial number of the blocking session, we can terminate the blocking contention in the database. So this is how we can resolve a blocking log contention in the database to avoid severe performance issues in the database environment. Now that we have resolved our blocking log contention, we should also receive a corresponding clear alert from the metric extension that we designed. So let's go to inbox, and there we go. We have received a clear message, EM event cleared, blocking log cleared, 4 minutes is 0. And here are the details. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it, and subscribe to my channel so you won't miss an episode in this series for the Oracle DBS or similar educational videos that I am uploading every week.